Okay, so my company right now, we are doing on a project to converting, multi-byte project to Unicode. So this involved the backend database change. Originally, the character set, basically the current character set is NC, which is American, blah, 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 and then WP1.
Western European ISO
Exactly.
88591.
Exactly. And then we're going to change to AL 32 UTF-8. Yeah. So one question I have is, let's say before we usually import some previous, for the clean installation, meaning if we create a new database now, we know how to do it, blah, blah, blah. But let's say we have a feature that we support the user that import a old project into the database. So basically meaning now, let's say I have a UTF-8 character set database, right? But the customer has a project has a exported file which can embedded the old character set.
Sure.
So, yeah. So in that case, which is Western European, that so when we import it, I'm hoping that it won't involve conversion, because it's what do you think?
So one question, just out of curiosity. The data that you import, and that is, let's say, not English, is what other language is it?
The thing is kind of tricky in no matter what kind of language we use. We actually cover 3 languages, but Japanese, Chinese, and Korean. But it doesn't matter. We actually using Microsoft compiler to compile it to multi-byte data. And when we really compile it to multi-byte data, we we didn't using the language setting on the client to let Oracle to convert it, but we actually specify on the serverless client. We actually let it pass through to store it as a series of bytes instead of really language setting. Do you understand what I mean? So
yeah, even pass-through configuration, we call it.
Exactly. So even let's say it's a Chinese system, but we compile it as a serious byte, and then we specified, we didn't say it's a Chinese, we say still we specify it's a English, let's say Western WP1. So we sort of faking the Oracle system that don't touch data, save it as is, and then later on when we read, we do that as well. So when we do import, even it's a Chinese, but it's treated, we still specify is a Western.
But so, what is the file format of this data that you are importing? Is it like data pump import, or some specific application that you use to import? How is this data stored?
Yeah, we actually using the old utility of Oracle's, like a EXP, the utility called the EXP export, and then when we do import, we use IMP. Yeah. So that's pretty much, and that.
In this case, you do have a problem.
Okay.
Because import by design will do character set conversion. So now I assume that in this target database, which is AL32 UTF-8,
yeah,
you already stored the data correctly. So you are no longer cheating, right?
No.
So it's already stored correctly in Unicode, right?
Yes, correct.
So what you actually need to happen is to, it's a complex problem, because your import file will contain, let's say, Chinese data in some Chinese character set, I understand, right?
Well, the data itself true, but when we specify the
Yeah,
character,
I understand. I understand.
yeah,
So,
yeah,
so what I
yeah.
say, the data itself. So this is the difference that I always make. The data itself is in GBK or whatever is the character set, right?
Yeah, that's
I
correct.
assume
That
it's
is
probably
fine.
the Windows Chinese character set, for example, right? For
Yeah,
simplifying.
yeah, correct.
So this is the GBK character set, right? It's called at Oracle. It is CHS 16 GBK.
Yeah,
Right?
yeah, yeah.
So this is the data. The file itself is tagged with the WE8 ISO 8859P1 character set, right? So we know this is already cheating, right? So this is not correctly marked, right? But the problem is what should happen for your data is to get converted from GBK to Unicode UTF-8, to AL32 UTF-8, right? This is what you would like to happen, because the data is in one character set and it should be converted to the target character set. However, of course, what will happen is that Oracle will see that the file is tagged as P1 and will do conversion, but it will not convert from GBK to AL32 UTF-8. It will convert from P1 to AL32 UTF-8. And there is no way to avoid it, because this is by design, right? Import assumes that there is no cheating, right? So and there is no backdoor that I remember. There is no backdoor in import to actually switch this conversion off, right? So I think there was some backdoor long time ago, like in Oracle 7 or something like this. So in current version, there is no longer any backdoor. So you need basically to design some kind of a bridge, right, that will allow you to import this type of data. And one idea would be probably, it sounds complex, but you have this issue, so you have to work around this, right? One thing that I would probably try, because I assume these projects are not very large files, right? So we are not very concerned about performance.
I'm not 100% sure. Let's say, assuming it's a small one. One situation is, even for now, what I'm saying is, we actually all our even we specify the Unicode, let's say it AL32 UTF-8 character set, but for all the string columns, we actually using byte. The varchar is a byte, not character, not car. Not car type. So that's because we actually do originally store all the series of byte instead of character based. So for UTF-8, we want to do that as well. So meaning that when it's trying to, the thing is, let's say when we do import the file, which is even the data is Chinese character, but the file is specified is the WP1. Even Oracle trying to convert it, but when it's seeing it's going to convert it from WP1 to Unicode, right? But when they do that, since it's a Western to Unicode, it's pretty much no conversion happens, because it's pretty much English to.
Actually, there is a conversion happening which totally destroys data if it is Chinese. So it's it's worse, I would say, right? Because it will, so if conversion, so import will switch on the conversion from WE8P1 to Unicode, right? Because there is a difference between the import file and the database, right? So import expects data that needs to be converted. So it will try to convert it. However, it will look at any non-ASCII byte, right? And there are a lot of such bytes in Chinese character set, right? It will treat it as some Western European letters, accented letters, right? And it will convert them into their corresponding 2-byte codes in Unicode, right? In UTF-8, because most Western European letters are 2 bytes in UTF-8. So each Chinese character that, let's say, consists of two bytes, both larger than 127, it will become some 4 more or less logically random bytes, right? Because there is no real correspondence between those bytes, because they were converted incorrectly from P1, right? So you will have a total chaos in the database. So don't even try to import this data if this data is stored as varchar2 in the file, right?
Okay.
So what you have to do is you need to have an intermediate database, right? In P1,
yeah,
which is almost empty. It just is kind of an interface database where you can do cleansing of the data, right? So you have this, when you do this import, right? You import into this P1 database, then you have the pass-through scenaririo, right? Data is not touched. It's converted from P1 to P1, so nothing happens to the data. It is stored there, and then, right, you need to somehow encode this data so that you can transfer it to the AL32 UTF database, and then convert it correctly into varchar2, right? So what you can do is, for example, depending on how long the columns are and what version of the database you are actually using, you can, for example, convert this data. There is a package called UTL_I18N, right? This is one of the standard packages that come, which has some conversion functions. And it has conversion functions that allow you to. There's another one which is called UTL_raw, and it has also a useful function that could be, which is called cast to raw, right? And you can use you can use this function to transfer this varchar2 data into the raw data type, right? Into a second column, which is the raw data type. Right? The only problem with this approach is, of course, that unless you use the longer strings, I mean the max string size equally extended in Oracle 12, right? The maximum size of a raw column is 2,000 bytes, and maximum size of a varchar2 column is 4,000 bytes. So if you have 4,000 bytes, you cannot move it into raw unless you are in 12.1 and you can enable longer raw, because then raw is 32K. But anyway, let's assume that there are shorter columns, right? That are up to 2,000 bytes. Then you can transfer this varchar2 data into raw. Then it is really treated by Oracle as a sequence of bytes, because the raw data type, right, is a sequence of bytes. We don't try any conversion. It's up to the user how to interpret this data. We just treat it as binary data, right? And then when you have this data in raw, then you can transfer it to the AL32 UTF database with whatever mean you want. A database link would be a simplest one, probably, right? You can then transfer it to a staging table in AL32 UTF-8 database, right? And then you can use a procedure from this UTL_I18N package, which is called, I think, raw to string or something. I would have to check the exact name, but it will allow you to convert from raw to varchar2 with conversion, And then you can decide what is the conversion. So you tell this function what is the character set, the real character set of data in this raw column, right? So the whole process would look like this. You import your P1 file with GBK data into this intermediate P1 database. There you copy this data using UTL raw, cast to raw, by simply moving it's kind of a cast, right? But you cannot use the cast function because the cast function would do something else. You need to use this UTL raw package, and then you kind of move the bytes untouched to a raw column, and then this is raw data. Then you can transfer it to the AL32 UTF database. This is still GBK data. It is no longer P1 because it's now raw.
Yeah.
So it's just bytes. You know that they are in GBK, but there is no character set tagging anymore. You lost this information that it was tagged as P1, which is good because this was wrong tag, right? And then once this raw data is in the AL32 UTF-8 database, then you can use this second function from the UTL IATN package, where you convert the raw data, the raw bytes, to the varchar2, and then you actually do the character set conversion. Because you specify to this function that the source character set is ZHS 16GBK, and then this function will transfer the data from the raw to varchar2, at the same time converting them from GBK to the target AL32 UTF-8. And then at the end, you have the actual Chinese data encoded in UTF-8, and then this is clean situation. And then Oracle is no longer complaining that you are trying to cheat. Right.
Okay. One question is I do have is, let's say now I have a not GPK data, but it's a English system. You know, let's say we actually test the English, so we haven't tested multi-byte language yet. So if we right now we just using the English system and then to import the WP1 to UTF-8, that conversion converge correctly.
No, so okay, let me explain. The problem is that English data just uses the basic 26 Latin letters, right?
Yeah.
This is this is the 7-bit ASCII character set.
Yeah.
And these codes, this particular 127 bytes, have exactly the same meaning in practically all character sets supported by the database. So the meaning of these bytes is the same in ZHS 16GBK or WE8 ISO or UTF-8. This is exactly the same byte, has the same meaning. So the conversion happens, but for those particular bytes, the conversion basically does nothing. So it converts to itself.
I see.
It does work. It does work. The conversion is there. Okay. It is the wrong conversion, but you have the luck that these are the data that has exactly the same look in all character sets that we currently support, right? There are only EBSD character sets have different encoding, but this is dying platform. So, you know, there's one platform that we still support with this character set, Fujitsu BS2000. So, you know, nobody uses it compared to, so there are people, of course, using it, but there are, compared to other systems, it's just a very minority, very small minority. So, so it's why you see, it's why this testing is not really
valid.
It's not really valid, right? Because it happens to work fine, but actually the whole process is not working fine. If you take instead of English data, you take French data or German data, right? Then then most data will look fine because these are still Latin letters. But if you have any accented letters like E with an accent or umlaut over A or U, like in German, right? Then these characters will be lost. They will convert to something very strange, right?
So there is
so one correction. Sorry, actually, I made one mistake. So actually, French and German with P1 are actually fine because this is a character set which is correct for those languages. But if you if you use some I don't know, Polish or Russian or some other that is not supported by P1, then it won't work. Right? Chinese
Okay.
is another example. Japanese is an example. Korean is an example. They won't work because they are not supported properly by P1.
Okay, so there isn't any way of, let's say, the only thing I was hoping for is the import utility. Is there any way that we can fake the utility that don't do any conversion?
No.
No.
No, there
No
is
way.
no such way. There's no such
Okay.
way. You can, no, basically nothing, right? You
It
only
always.
if you have normally if you have to transfer data between two databases and there is this type of cheating somewhere underway, then the solution is usually to use a text format as an intermediate format, right? So if you have a control over format, then you can write a simple utility or just a script in SQL Plus where you just strip all headings or whatever and produce a CSV file, right? Actually, I think newest SQL Plus has even a built-in CSV support. So then you can produce a text file. So you can like start SQL Plus with NLS lang set to P1, right? Then export your data from your P1 database. This will be just exported without, I mean, spooled actually, right? Without any conversion. And then you have a text file. And the good thing about text file is it has no character set tagging, right? So it does not know what is the character set. It's up to you to pass it further correctly. So if you take this file and then load it into another database using SQL Loader, then in the SQL Loader control file, you have the character set clause, and you can declare the character set of your choice. And then you can say it is ZHS 16 GBK, and then this data will be converted to AL32 UTF-8, but correctly from GBK and not from P1. But you can only do this if text is the intermediate format. If this is import, whether it is data pump or it is an old import export, it doesn't matter. The effect is the same, right? Both will do character set conversion, right? Because they assume the data is stored correctly and they try to save you the problem of configuring things and so on. So they have the tagging internally and they try to do the right conversion for you, right? So you don't have to worry about doing the conversion. Unfortunately, of course, if the data is originally stored incorrectly in the database, then of course you have a problem because what Oracle thinks is good is not really good for your data. Then you have to do some these intermediate steps that I have described as a possible workaround. It was the quickest one that I just thought of, right? The one problem is that if you have your data in a database, so you have a P1 database and AL32 UTF-8 database, and you want to move this data through database link, right? Then you can do some simplified process using views which employ this UTL underscore cast to raw, for example, right? And then you can pull the data using database links by casting the data to raw and then back to varchar 2 and doing the right conversion underway, right? Okay. So you just make sure that the raw data goes to database link. But then, in this case, the source must be the database. If your source data is already in the import file, right, then you have to first import it to some database so that you can actually do the cheating. Right?
Yeah. So one question is that utility has an option that when I say to specify, let's say, even I'm not the Unicode data, but I will specify, let's say when I do import, I will specify, I'm telling Oracle that if the utility has an option, I can say, I'm UTF-8, let's say.
No.
So no.
The import has such option only for if you try to import like Oracle 5 files. Very old files, because there are such large command line options. So they may be confusing because people think that they will help. They will not. these options are used for very, very old files from the times where there was no correct characters and tagging, in which case you can actually say what's the source character set. But if the import sees that this is a more contemporary file, right, from some current database version, actually Oracle 7 or newer, right, then it won't look at this command line parameters anymore. It will just use the information it already has in the import file, right?
So okay, so when we use the EXP utility, meaning the export utility, to generate the exported Oracle file, data file, that's the character set already embedded into it.
Yes.
Is that correct?
Yes.
Oh, I see.
There is a special tag inside this binary file that tells what's the character set of the data.
I see. Okay, so from WP1 to Unicode, there is actually there is a conversion. It's just depending.
Yes,
oh,
there
I
is
see.
conversion.
Okay.
You just don't see effect of this conversion on if you
English system. Yeah. Okay, I see. Okay, thank you very much, Tom. That's very clear to me. Okay, thank you.
Welcome. Okay, I see some further questions in the chat. Let's see. The first question is, one Unicode character stores in more than 2 bytes or in only 1 byte. So, so first thing is Unicode has a few encoding forms. For the Unicode that we use as the character set for the database, varchar 2 columns, so which is like AL32 UTF-8. This is a variable width character set, which means that the characters occupy from like 1 to 4 bytes, depending on a particular character, right? So all characters that correspond to the US7 ASCII character set, so 7-bit ASCII characters, they occupy 1 byte. Most European scripts, like accented letters or Russian, Greek letters, also Arabic or Hebrew letters, they will occupy 2 bytes. Most other scripts, like Indian scripts or like East Asian scripts, Japanese, Chinese, Korean, they will occupy 3 bytes per characters. And there are also a few characters. There are also some characters like some Chinese letters, but I don't know, musical characters or maybe some emojis and things like this. They can even occupy 4 bytes. So this is like in AL32 UTF-8. If you use AL16 UTF-16 with nchar or nvarchar 2, then it's different. Then most characters will use actually 2 bytes, except for those characters that occupy 4 bytes in AL32 UTF-8. They will also occupy 4 bytes in AL16 UTF-16. So these are these rare characters like musical symbols or emojis or some historical Chinese letters. I hope this answered the question. If not, then please let me know on the chat or just unmute yourself. And the second question from Judith is, what are the pros cons of choosing UTF-8 versus AL32 UTF-8? There are no pros really for using UTF-8 because this is a deprecated character set, and this is not really UTF-8. It's actually a CESU8 encoding. We just historically used this name in old times where the encodings were not yet well standardized, and this is like a artifact from those times. So UTF-8 just don't use it. Use AL32 UTF-8, which is the actual implementation of the UTF-8 standard for the database character set. So this is why the Oracle recommends AL32 UTF-8. instead of this deprecated UTF-8. What are the pros and cons of choosing a Unicode database character set? National character set. The main, so like why Unicode with varchar 2 and not the Unicode data types? This is mainly because of the depth of the support, right? So any new feature will basically support varchar 2 data types and the AL32 UTF-8 character set. And there are features that do not support the national character set. Oracle Text does not support it, and there are some, I think XDB does not support it either. So you don't have the full functionality available with those data types. This is one problem. The second problem is that unless you do a specific settings on the client side when processing in varchar 2 columns, the data when going from the client to the varchar 2 columns will actually go through character set convert to the data character set, so you may actually lose those data. Yeah, so as I said, UTF-8 is actually CESU8 character set, and I know that there are situations like, I think SAP actually wants this character set to be used for their database as the Unicode character set, and they have some specific reasons for it, which are interfacing with Java and like a better corresponding of character versus code, right? Because both UTF-8 and Java, they use the surrogate pairs to encode some rare characters, while AL32 UTF-8 actually uses a single character code for those. However, the UTF-8, we don't guarantee that all letter character classification is correct, and you will have the newest support. We formally support only version 3.0 with UTF-8. So you can store those characters in the CESU8 form, but you don't get the guarantee that all characters are properly classified when you want to use them or process them, for example, in Oracle Text or in some other features that may need this classification.